Hey everybody, this is Mr. Beckstrom again, and today we're going to be talking about Chapter 4, Section 4, Cones and Frustums of Cones. So let's first define what a cone is. A cone is a pyramid-like figure with a circular base. You can see here, we talk about R, that's the radius of our base. H would be our height or our altitude. That's from the center of the base to the vertex. And we have S, that would be our slant height. That's the length of the side of this cone. So we have some formulas for the cones. The lateral surface area, that's the surface area around the side of the cone. That's going to be pi times the radius of our base times our slant height, or 1/2 pi times the diameter times the slant height. And then we also have the total surface area, so that would be the lateral surface area plus the area of our base. I just put an A for that area, but the area formula for the area of a circle is just pi r squared. And then we also have the volume, and we have a couple of different formulas here. You can do 1/3 pi times the radius squared times height, or you can convert that to diameter formula, and you also have a decimal approximation, which will give you to within about 4 decimal places of the correct answer. Alright, so let's look at the first exercise. Let's find the lateral surface area, total surface area, and the volume of this cone here. So looking at it, we see we have a radius of 3.5, we have a height of 8.4 centimeters, and a slant height of 9.1. So let's jot that down. What I like to do is just put the variable letter down and write down the length. That way I can plug those right into the formula. So the solution for the lateral surface area, we'll use the one with the radius. So that's pi times our radius, which is 3.5, times our slant height, which is 9.1, which comes out to approximately 100.06 centimeters squared. Remember, when we're talking about area, we always put the unit squared. When we're talking about volume, we always put the unit cubed. The total surface area, well, we're just going to take our lateral surface area, and that's why we did our lateral surface area first. So that way we can just plug that into our total surface area plus the area of the base. We already said the area of the base is pi r squared. So just plugging in the radius of 3.5, squaring it, and then multiplying that by pi. We're going to get 38.48 plus our 100.06 from our lateral surface area to get a total surface area of 138.54 centimeters squared. Remember, when we're doing these formulas, to do the exponents before we do the multiplication. We need to remember our order of operations. So if you need a reminder of that, I believe I have one up on Moodle, and you can also just Google order of operations, and you'll get some pretty in-depth guides on that. Alright, going to the next shape we have. It's the frustum of a cone, very similar to a frustum of a pyramid. We take a cone, we cut off a section of the cone. That slice has to be parallel to the base of our cone, so then we get two parallel bases. We call it base 1 and base 2. And you can see here I've labeled the radiuses. I call the top radius 1, the bottom radius 2. However, you can name them whatever you want as long as you're consistent. If you want to call the smaller of the two bases R1, you can do that. If you want to call the larger of the two bases R1, you can do that. Just make sure that you stay consistent with any future formulas you're trying to compute. Alright, so let's go over the formulas. So the lateral surface area is pi times the slant height times the sum of the two radiuses, or radii. This would be the base 1 and the base 2 radius. And then you can also convert that into a diameter formula as well. The total surface area, we're just going to take that lateral surface area, which is the area around the side of this frustum, and add the area of the two bases. So that'd be pi r1 squared plus pi r2 squared. And then finally the volume. This is a much more involved formula, so let's talk a little bit about how we want to proceed putting this into a calculator. It's nice if we have a calculator that is either scientific or graphing, in which we can put the entire equation in, so we can make sure the order of operations are done in the right order. However, if we just have a regular calculator that just has that single display, I'll let you know how we would put that in that calculator. So this is 1/3 times pi times our altitude times the sum of the radius 1 squared plus the radius 2 squared plus the radius 1 times the radius 2. And then there's also an equivalent diameter formula for that as well. Alright, so let's take a look at example 2. Let's find the lateral surface area, total surface area, and volume of this frustum here. So I'm going to jot down maybe on the side. I can use either diameter or radius. In this case, I'm going to convert this to radius. It just makes it easier if I just want to write down the formulas that have the radius in them. So I'll say that R1 is equal to half of that, which is 2. R2 would be half of this, which is 6. My height is 8, and my slant height is 10. Alright, so let's go to our formulas that we had before. So I'm just going to, for the lateral surface area, I'm just going to go ahead and plug in my 2 and 8 for my radius 1 and my radius 2 with my height, my slant height of 10, and multiply that by pi. Remember, we do what's in the parentheses first. So this would be 10 times 10, which is 100, times pi, which is approximately 3.1416 when rounded to the 100th place, square inches. And the total surface area is going to be that lateral surface area that we just computed, plus the area of the two bases. So that's going to be the lateral surface area of 314.16, and this would be pi r squared here, where my radius is 2. So I would do 2 squared, which is 4, times pi, which is approximately 12.57. And then here I'm going to do the pi r squared with the bottom base, which has a radius of 8. So that'd be 8 squared, which is 64, times 3.14, which comes out to approximately 201.06. Add those together, and we get the 527.79 square inches. Alright, with the volume here, this is going to be a little bit more complex, like we said earlier. So let's make sure that we plug all the numbers in correctly. So I just go straight from my formula. I plug in my height. I plug in my radius of my top circle, which is 4. The radius of my top circle squared, which is 2 squared, which is 4. The radius of my bottom circle squared, which is 8 squared, or 64, plus my radius of my top circle times my radius of my smaller circle, or bottom circle. And when we do that, let's see how we would put this in a calculator. So if I had a graphing or a scientific calculator, I could just put it in just like that. And as long as I put the parentheses where they go, it should do it correctly. However, if I was just going to put this into a regular calculator, I would start with the inside parenthesis here. So I do 2 times 8, I get 16. I'm going to add that to 64, and it gives me 80. And then I'm going to add that to 4, which gives me 84. And then I'm going to take that 84 and multiply that by 8. And then I'm going to multiply that by pi. And then I can either multiply by 1/3 or I can divide by 3. And in the case of just kind of an ordinary calculator, I just divide by 3. And I'm going to get approximately 703.72 inches cubed. All right, please email me or give me a call if you have any questions, and we'll look forward to the next section review. Thank you.